The next session is called Applied Mineralogy as a Tool to Research the Provenance and Technology of Ancient Ceramics. Many of you probably do not know that the study of ancient ceramics in the U.S. actually started here at Carnegie in the 1940s and 50s by two women scientists, Anna Shepard, who looked at the petrography and did refiring studies of Southwest pottery, and by Marie Farnsworth, who studied classical Greek pottery using X-ray diffraction, atomic absorption, and other trace element techniques. In 1952, Homer Thompson, who'd been an archaeologist excavating the Keramikos near the Parthenon in Greece, organized, after whom Indiana Jones was modeled quite appropriately down to the hat, organized a meeting at the Princeton Center for Advanced Studies with Libby of C14 date, fame, Sayer, Brookhaven, who developed INAA, and others to propose how to apply science to archaeological and art objects, given the constraints of sampling, for instance, preferable use of NDE techniques, to study variability, to reverse engineer ancient pyrotechnologies, to determine rate-limiting steps in processing that oftentimes are skewed in distribution as you run up against materials constraints, and that actually can be extrapolated and interpreted to get at decision-making and behavior of ancient peoples. So with this in mind, we're going to have two papers today. They're going to be in inverse order as they're listed in the program. The first is going to be by Gilberto Artioli of the Department of Geosciences at the University of Padova. Modern Mineralogy in Ancient Pots, the Archaeometry of Ceramics, and the second by Michael Tite of the Research Laboratory for Archaeometry and the History of Art at Oxford University, and the former head of scientific research at the British Museum. And his talk will be called The Mineralogy of Opaque Ceramic Glazes, Development in the Islamic World and Europe from the 7th to 16th Centuries Christian Era.
Well, thank you very much for the invitation. Also to Bob Hyman, is not here, couldn't come because of flight, but he's an expert on, of course, modern and ancient ceramics. So is Mike Tite. So I feel a little bit ashamed of actually talking about ceramics, which I'm not an expert, but I'll try to do my best to show at least what archaeometry is about. We are up to something a little bit different from what we heard up to now. So archaeometry, recently in the encyclopedia, Tite wrote it was kind enough to prepare the voice archaeometry, and said it's an obsolete term. So many of the people goes for archaeological sciences, and I discovered quickly that conservators and conservation science and archaeologists, that they follow different training, different careers, different techniques. As a material science, I could totally disagree. I mean, the techniques are the same. We use the same instruments. We are facing the same phases, mineral phases, and I feel the topic should be the same and should be addressed by somebody that has a deep understanding of the materials, and this is still to go by. Here are some of the major journals in the field: Archaeometry, Archaeological Sciences Journal, Archaeological Anthropological Science, and then there are now a number of new ones, Open Access and others, which are actually, which are actually very strange, and they are attracting people. We are flooded with the requests of publications right now. And then there are other more specialized journals, like This Is More Conservation and Geoarchaeology, just showing that it is a parallel field. You know, a lot of mineralogists, a lot of geologists are actually working in this area, and they are bringing a lot of knowledge, and I'll try to show you what is the way of doing it. Are the questions clear enough? Yes, in the traditional field. We all have material science or a mineralogical background. We do have a deep characterization, interpretation of the materials. Conservators aim to diagnosis of the problems, like for restoration, authentication, preservation of the objects in the museums. I think mineral collections is going this way in the same way. There are fakes because of high prices, exactly as in artwork and archaeological materials. There are parallels that we can make. Whereas archaeologists usually bring you a material they don't know anything about. About 30% of the objects arriving in our laboratories are unknown to the archaeologists. They are missed. They give you a metal in place of a slag, a ceramic in place of something else. So it's, there are problems. The way I see it is that we should actually put the object, the material, it can be small or large, into a timeline. There is a production process, usually in the past. It may be an artwork, pottery, as we are talking about. As soon as we do something, we bring it to a metastable state. It can reach a metastable equilibrium. Well, the material is always trying to go back. So basically, you produce a metal, you reduce it, it's starting to oxidize, and then it is being used during a historical or prehistorical period. And then, of course, there is some rusting, there is some diffusion, is brought in a different environment, is always trying to go back, and then it falls into, with diagenesis or corrosion, into the archaeological record, and then archaeological excavation suddenly brings it again into a different state. And then the conservator again is trying to preserve it into a state that is not natural. So there are a lot of problems in dealing with archaeological material or our historical materials that are not common with modern materials. I put this, this is the room we are in. If you look to your left, there is hard science, like physics, chemistry and geology. If you look to your right, there is archaeology. It's not by chance that they've been divided into soft science, anthropology, archaeology, and hard science. Because they traditionally, in the past, they felt like very different disciplines, having different careers, backgrounds, and exchange. And to date, I think that we do have actually some communication problem. If you ever tried to do, like, for example, crystallographic texture analysis and explain what inverse pole figures are to an archaeologist, you understand what I mean. The other problem is that very often they do not understand at all what they are talking about techniques. They give you the material, and usually, if it's not organized, and this is one of the problems, there is no interface between the two worlds, and we need to do that. Some places like ESRF in France has worked a lot with the Center of Research of the Museums. The British are a little bit organized. In many other countries, there is absolutely no interface between the two communities. So if you go on a personal basis, the archaeologists give the material to a mineralogist, and we go for diffraction, SEM, and the usual techniques. It goes to a chemist, and he gets FTIR usually, or Raman spectroscopy, and it goes to the physicist, and it goes into TEM or ultraviolet or photoemission spectroscopy or this kind of stuff. And of course, the archaeologists will never understand that if the material is one, the answers are many, and you should have complementary information, to put it together in order to interpret it fully. And this is kind of the problems. I mean, if you don't come to us with real questions or well-prepared, well-thought questions, then you have the reverse problem, that the scientist, which is totally unaware of the problems, takes the material and gives the wrong answer. And that's exactly the depicted case. So we all know that we can look at the materials at different scales, and that's natural for us. And if you translate that to an archaeological excavation, we can go from the aerial large-scale survey into what is called now molecular archaeology, and I'll show something about that. This is actually a real excavation we followed in Sudan, where we had to do from landscape, archaeology up to, very detailed analysis. And we got some very interesting results. So what I've been trying to put forward is that, and it's my firm belief, is that mineralogy, or somebody that knows very well the natural materials, has advantages with respect to other sciences, because we do have a perception of the complexity of natural materials. You take a rock or a mineral, and as we all know, if you have enough sensitivity, you find a full periodical table. And then knowing crystallography, material science, phase transition, microbeam techniques, all sorts of things, advanced radiation. So I'll talk a little bit about that. Geochemistry helps a lot when you're facing, complex material like the one used in the past by humans. The first book about this was George Riprap, Archaeomineralogy, and we have been trying to do something with elements, and this is coming in a few weeks. So this is just to give you an idea that it is not just the pottery and the ceramics I will talk, but it's an interface. It's a problem of two communities that needs to communicate. Archaeologists and art historians badly need scientists like mineralogists. I think this is, we can do something for the community and in the humanities. So ceramics. If you deal with the modern ceramics and the idea of the material is totally different from what is perceived by the archaeologists or the art historians. Engineers usually put into ceramics everything, which is from fine ceramics to refractory, including cement and glass and potteries, of course. And so we deal with the kind of material that go from superconductors to silicon carbides or boron nitrides or whatever. And this is not the case in traditional investigations of archaeological ceramics, which are more related to traditional, earthenware, stoneware, porcelain. We deal a little bit, and with the traditional way of making potteries, which is, shifting into anthropology and, of course, traditional craftsmanship. Why are ceramics important to the archaeologist? First of all, they survive. So it's the most common objects, found in archaeological excavation. They go in tons of shards. And if you ask one to cut it up, they say no, it's too precious. They have a cultural significance, of course, not just the material aspect that we'll deal with from the characterization, but of course they show various aspects of our past, depicting scenes and bearing profound historical and cultural significance. And there is a developed scheme of chronology based on pottery, because they are ubiquitous and they are, fast changing. I will get back to that. No, I will not deal with the technology of ceramics. I think most of you know very well. I mean, what it's based on basically clays and silica as the inert phase, and some fluxant. And basically most of the material, ancient and modern, that we found is in a diagram like that. And if you want to convert it into a calcium aluminum silica, there we are. Again, we do have most of the normal ceramics and all the other materials that engineers consider that. Of course, we go a little bit deeper than that. We do know the phase diagrams and what happens in the process. So we should be able to interpret the process in terms of the phases forming and the kinetics and the temperature of the oxidation and whatever. So the first thing that traditionally it has been done with the archaeological potteries is to look at the mineralogy, of course, the composition and the formation of the minerals at different temperatures are indicative of the process. So again, it is an inverse process. We are looking at the pottery that is being made, a long time ago, and we need to interpret the manufacturing, the raw materials, the firing, the oxidation condition, the temperature, and whatever. How do we do that? We do with all the techniques that we know and we have available. From DTA and thermogravimetry, we know the porosity and the conditions are related to the traditional classes that I briefly introduced are related to, of course, the time or temperature of firing and the final density. And historically, we usually find materials with at least 10–20% porosity. Modern materials are, of course, much more dense. And this depends on the sintering and the completion of the thermodynamical firing. And this also gives you an idea that there is no clear distinction between the ceramics, like the pottery I've shown, and other materials like glasses and glazes that Mike will talk about. We can go from materials that are pure amorphous glass, true glass, through materials that are, this is a kind of glassy faience, 50-50 more or less, glass and crystals, or faience that has, less than 10% glaze or glass in the matrix or at the surface. And then we go to materials which are frits, usually called. It's a material that has never met fully molten state, but there is a transition. It goes into cuprorivayite, which is one of the pigments used by the Egyptian, or the ceramics we've been talking about. So if we look at the pottery, what do we look? If we look at, with some kind of microscopy, we do have crystals, a substantial amount of glass materials, and sometimes we find exotic things like, relics of phytoliths due to the dung or plants used in the paste. We found signs of incomplete burning. Mossbauer spectroscopy is a very good technique to understand the completion or the incompletion of the reaction or the firing or the atmosphere where it has gone about. So this is the kind of stuff that traditionally the petrologists and the mineralogists do for the archaeologists. This is traditional, let's say, techniques, diffraction, Mossbauer spectroscopy, optical microscopy, electron microscopy, DTA, and whatever. Let's step back a little bit and see the other part, the archaeological part. Ceramic in time started a long time ago. This is not even fired. This is the first, maybe, ceramics is not pottery, is figurines. That's very interesting because many of the materials, including metals and others, they were not used for practical purposes in the beginning, but for some kind of symbolic values. And then they go back into the very practical because they understand the technique, they how to use, and then they go back, for example, for the symbolic values. Like metals, for example, they start as ornaments and then tools, and then we use it as money, which is, a symbolic value of some sort. For pottery, the early ones, these are very recent data. We can discuss a little bit about the dates, but we have very early China, Eastern Siberia and Japan. These are the earliest pottery known up to date. And it's very interesting to observe that the making of pottery is before what is considered like the settlement of sedimentary community with agriculture and everything. So they were still hunter-gatherers, but they started to use materials of this kind. And maybe Pam can add something she knows much better than I do on these materials. This is all very recent stuff. Okay, before the Chinese and Siberian occurrences that cropped up in the last 10 years or so, the earliest one was the Yomon culture in Japan, which I love. I mean, this is fantastic, very old figurines. And again, some of the pottery was totally, I don't think, usable for practical purposes, but it's amazing, definitely. So, ceramic is not only, a material that you use for tools, for food, and other things. So we'll get back to that. But of course, it gives you a lot of information on the aesthetics, the values, the community, the anthropological side of the stuff. This is actually tattoos on the figurine that tells you a lot of what it meant. And of course, writing has, again, a lot to do with ceramics. All the early writings is made on cuneiform tablets. And then we, of course, evolve into different cultures and technologies. That's what we need to decode and couple with the anthropological symbolical values and put together with the material science that we know, more or less. I will not go into the luster of Renaissance because I hope that Mike will talk about that. But there is, of course, a big evolution of the techniques. This is the Robbia and the beautiful Renaissance materials. I'll just show you this painted terracotta. I think is wonderful. It's Central Italy in the 1400. And there are very specific type of ceramics again. I'm not going to dwell into that. This is the Rako of Japan. This is the very famous Celadon from China. And each one has specific, yes, time is out? Or, finish, okay. This is Tiffany, that's very local then. Let's skip this. If you look into the archaeological literature, it's full of this chronology based on the evolution of typology, more or less. And we can do something better, I think, by using a little bit of modern techniques. Neutron diffraction is totally non-invasive, and you can do imaging and diffraction and spectroscopy at the same time, which I think is one of the bonus of modern material science. The neutrons, or even if you go to a synchrotron, you can do imaging, diffraction, spectroscopy at the same time. For example, we can reconstruct the shape of the material, in this case the ceramics, look at the feldspar inside, reconstructing the image in the sinogram, either with the diffraction peak or with the XRF peaks. And you do have a 3D non-invasive technique to visualize the components of the ceramic inside. Provenancing is done with traces, trace elements, lead isotopes or traces, as we all know for geochemistry. As long as you have the database, you can use it. And firing conditions, Mosbauer is performed. Usually, sometimes you do refire the ceramic and measure the magnetic susceptibility or the restarting of the kinetics of the firing by decomposing some of the phases, and then you understand at which temperature it was fired. Thermoluminescence, we can add. I conclude. Okay, let's go back. Just this. The material science is not the whole picture, because if you look at these pots and if you look with the eye of a material scientist, then you might not understand it was used for dancing. Okay, you might interpret it differently. So there is a material science part of the material and a symbolic value. And there are a lot of materials that we absolutely don't know, no clue of how they were used technically. I will skip all the rest by just saying that organic residues in and the organic materials in pottery is a big theme and is one of the most modern, evolution of the stuff. I'm stopping. Sorry about that.